We are a niche foundry. We specialize in leak-free, pressure-tight castings. We expect our aluminum castings to machine like bar stock and billet material. We're also a Petrobond foundry, whereby we bring a very superior surface finish to the table. Hello, I'm Mike Stahl, Olson Aluminum Castings. I'm going to show you how to make aluminum castings the Olson way. There's a couple things we bring to the table that are rather unique in our industry. First and foremost, we go to great lengths to cleanse our metal. We degas it in such a way whereby we strip out the hydrogen gas, we eliminate the porosity issues, thereby giving you a very tight grain structure. Another thing that we bring to the table, we also buy A-grade 356. We do not buy the commercial grade 356. A-grade will give you a much tighter grain structure. These are the type of properties that we're looking for in a casting that will allow us to produce consistently pressure-tight and leak-free castings. If you have to impregnate a casting to solve a leakage problem, that's a salvage operation. We've made castings for years, holding pressures as high as 4,000 psi in a working load. Never have had to impregnate a casting in the 26 plus years I've been with Olson Aluminum. Some of the issues that are typical of castings, oftentimes you'll see porosity that looks like what you see right here. This is actually a fuel valve, and this is typical of what many foundries produce and say is good enough. This part has to be 100% leak tested and impregnated. We took this project on, eliminated that type of a scenario, and we now have metal that looks more akin to what you see here. Free of voids, free of gas, free of any type of shrinkage porosity. By doing due diligence and paying attention to the basics, we can achieve this type of casting, if you will, on a routine basis on any number of shapes and sizes of casting. A couple examples of hydraulic applications. Obviously, impact tools for the hydraulic tool industry. Obviously, there's hydraulic pressure running through this casting throughout, along with a spool valve that's actually internal. Obviously, there can be no porosity on that for two reasons. One, you can't have the leakage, and two, you can't have pits on O-ring groove surfaces. It's another example of a casting that we produced, a customer of ours, again, a hydraulic application. Starts out as a raw casting as such, ultimately is machined and assembled, all done without any impregnation whatsoever. This would be another application where there's a significant amount of surface area that gets machined, and obviously this entire bore has to be free of any type of detrimental porosity. It is part of a fuel valve, a butterfly valve, if you will. Winds up going on industrial turbine engines. Again, we expect our material to finish and machine like bar stock and or billet material. We have another example of a fuel body. This gets machined extensively. Starts out as a sand casting out of our foundry. Again, it's holding pressure, and there is no impregnation being performed on this particular item. Not only will you notice that there are some machine surfaces that look phenomenal here, but also the surface finish on the as cast also looks superior. We actually use a Petrobond, an oil bonded sand in our process. It gives us some very good surface finishes. We're probably, I'm going to say 10% of the foundries maybe in the country are still using a Petrobond or an oil bonded sand. We prefer it because it does bring a consistency in the compactability, consequently a consistency in surface finish. We talk from time to time about conversions from prototype castings that are machined out of solid billet material. Here's an example of something that ultimately was proven out in the solid billet process. Obviously many machine hours went into it. We've turned it into a relatively near-net shaped casting. When it comes to specialized castings that require leak-free, pressure-tight characteristics, do it the Olson way, call us.